So now we move to the next level of difficulty, and we start to solve a quadratic equation. And so a quadratic equation is one of this form, ax squared plus bx plus c. So this time we have our variable, still just the one variable x, and there it is to the power 1, but I can now also have x to the power 2 in it. And in fact, if you look at it, what we have here is in fact a quadratic trinomial equal to 0. Remember we talked about quadratic trinomials last week and how to factorise them? Okay, so essentially if I've got a quadratic trinomial equal to 0, that's a quadratic equation. So, the interesting thing about these equations is that sometimes they have one solution, sometimes they have two, but sometimes they have none. So I don't know whether, before I start, whether I'm going to get none, one or two solutions to a quadratic equation. Whereas with a linear equation, I always knew I was going to get one solution. Yeah?
Could it possibly be three solutions?
Nope, never, never. It's always 0, 1 or 2. So, depending on, I can give you a method that works for every quadratic equation, but for some quadratic equations there are quicker methods. So I'm going to go through and do the quick methods first, and then finish up with the one that always works. Okay? So, the simplest quadratic equation to solve is one that doesn't have an x term in it. If it's just x squared and a number, that's dead easy to solve because I can say here x squared minus 4 is equal to 0. So therefore x squared is equal to 4. Just add 4 to both sides. And now I take the square root of both sides. And so x can be the square root of 4. And in this case, there's no reason why it can't be negative. So it could either be the positive square root or the negative square root. And so that is plus or minus 2. Would be the possible answers. So you can write x is equal to plus or minus 2, or you could write this, or you could say x is equal to 2, or x is equal to minus 2. Writing those two things is the same. It just says there are two solutions. And of course, if you go back and check, if I put x equal to 2, 2 squared is 4, 4 minus 4 is 0. Likewise, if I go back and put minus 2 in, minus 2 squared is 4, 4 minus 4 is 0. So both of those numbers work. So this is an example of having two solutions. Yeah?
Could you solve that using the difference of two squares?
Yes, you could. You could. Yeah, if you wanted to. You could say x squared minus, yeah, I'll put it in here, equal to 0. So therefore I can factorise that, as you recognised, is equal to 0. Now, I wasn't going to mention this until here, but I'll write it down here. If I've got two numbers, if a times b is equal to 0, then that says either a is equal to 0 or b is equal to 0. That's just an arithmetic fact. If two numbers multiply to be 0, one of them has to be 0. So keep that in mind. Let's put that there. That's important, because that's what we're doing here. I've got two numbers that are multiplying to be 0. So that says either that number is 0 or that number is 0. So I have x minus 2 is equal to 0 or x plus 2 is equal to 0. This is now a linear equation which I can solve. That says x is equal to 2. This one says x is equal to minus 2. Same answer. In this case, doing that's much quicker. However, in my next example, I don't have the possibility of making x the subject, right? Because I've got an x squared term in there and an x term. So I can't just take the square root of both sides. So once we get an x term in there, we have to factorise. We've got no choice. So in here, if I'm going to solve part A, x squared minus 4x equal to 0, I can factorise the left-hand side. That's x times x minus 4 is equal to 0. And so that says either x is 0 or x minus 4 is 0, i.e. x is equal to 4. So I have two solutions, 0 or 4. And of course, I've gone via that box to do that. The next one has all three terms, excuse me, in our quadratic trinomial. X squared minus 4x plus 3. I can't easily rearrange that and make x a subject, but I can easily factorise this quadratic trinomial on the left. Given that I've done all my exercises from last week and I'm now a gun factoriser of quadratic trinomials, right? I know here alpha plus beta has to be equal to minus 4 and alpha times beta has to be equal to 3. Given that this is a positive, they both have to be the same sign. Given that this is a negative, they both have to be negative. So I can see that that's going to be x minus 3, x minus 1 in there. It might take you a little bit longer to do it than that. But you multiply that out, I've got x squared, then I've got minus x minus 3x, gives me minus 4x. And minus 3 times minus 1 gives me plus 3. Having factorised it, that says either that number's 0 or that number is 0. So either x minus 3 is 0 or x minus 1 is 0. So therefore x is either equal to 3 or x is equal to 1. Having arrived at, in this case, two solutions, I then can say, well, look, am I correct? Well, let's check it. Let's put x equal to 3 back into my original equation. 3 squared is 9. 9 minus 4 times 3. 1 minus 12 is minus 3. Minus 3 plus 3, 0. Tick. I feel confident. Likewise with 1. 1 minus 4 is minus 3. Minus 3 plus 3, 0. Tick. So I know I got it right because I checked my answers. And wacko, here's some examples. Let's go through and do them. Whole lot of examples. So we'll start with A and work through, and we'll work our way through this. So this says, now at the moment this is x squared is equal to 6x plus 27. What I really want is quadratic trinomial equal to 0. So I actually want to write this as x squared minus 6x minus 27 is equal to 0. That's because I want two numbers multiplied together to give 0. I want a 0 on the right-hand side for my factorisation to work, factorisation technique. And so now I have to think to myself, in here, I have to factorise this. So I think to myself, look, alpha plus beta has to be minus 6. Alpha times beta has to be minus 27. I want two numbers that multiply to give minus 27. So one's going to be positive, one's going to be negative, because that's a negative. And here, when I add them up, it's going to be negative. So the largest one's going to be negative. So 3 and 9 seem pretty obvious, don't they? So to me, it looks to me like alpha is going to be minus 9, beta is going to be equal to 3. Minus 9 times 3 is minus 27. Minus 9 plus 3 is minus 6. And so there are my factors. I've got x minus 9, x plus 3 is equal to 0. So therefore x minus 9 is equal to 0, or x plus 3 is equal to 0. So I have 9 or minus 3. Done. I like these, I can do them. Well, I could do that one anyway. If you look at part B, again, it's not yet written in the form of quadratic trinomial equal to 0, so I rearrange it as quadratic trinomial equal to 0. So I just added 28 to both sides. Now I try to factorise this. Alpha plus beta is minus 11, alpha times beta is plus 28. So this says alpha and beta are the same sign in here. But they've both got to be negative, and they've got to add to 11, minus 11, in fact. Alpha plus beta is equal to minus 11. Alpha times beta has to be plus 28. So I would suggest to you something like minus 7 and minus 4 would work. Minus 7 times minus 4 is 28. Minus 7 minus 4 is minus 11. So there are my things. I've got m minus 7, m minus 4 is equal to 0. Sorry, m minus 4 is equal to 0. So therefore I have m is equal to 7 or m is equal to 4. So if you can factorise the quadratic trinomial, then you can solve the quadratic equation, is the moral of the story. In part C, we have a quadratic trinomial whose coefficient of x squared isn't 1. So in this case, I say alpha plus beta has to be 9, and alpha times beta, in this case, we want to be 2 times 10. So we want that to be 20 in here. So same sign, add to 9, looks like 5 and 4. So alpha is equal to 5, beta equal to 4, looks like it works. And then according to our method 4, or whatever we called it last week, I can say the factorisation of this is 2x plus 5 times 2x plus 4, all divided by 2, is equal to 0. That was from our factorising last week. As I said, I think we called it something inspiring like method 4 last week. But if you go back and have a look. Now last week, we found a common factor in one of these brackets and cancelled it out with the denominator. But given that this is an equation, I could just multiply both sides by 2. And the beauty of that is 0 times 2 is 0. And so I have in here either 2x plus 5 is equal to 0 or 2x plus 4 is equal to 0. And so this says x therefore is minus 5 on 2. Now that's minus 4, so that'll be minus 2 sitting there. And there are 2 solutions to my quadratic equation. Let me do one more. D. A plus 1 is equal to 6A squared. Once again, I want that in the form of quadratic trinomial equal to 0. So that's the same as saying 6A squared minus A minus 1 is equal to 0. So what did I do there? I subtracted A from both sides, I subtracted 1 from both sides. So I had 0 is equal to 6A squared minus A minus 1. Then I wrote it round the other way. All right, so I've done 3 steps in one go there. It's a quadratic trinomial. The coefficient here isn't 1, so I'm going to use my method 4 thingy again, and it will say alpha plus beta has to be minus 1, the coefficient of A, and alpha times beta has to be 6 times minus 1, which is minus 6. So this is negative, so these are of opposite sign. The largest one's going to be negative, so 6 and 1's not going to work, but I reckon alpha equal to minus 3, beta equal to plus 2 will work. Minus 3 times 2 is minus 6. Minus 3 plus 2 is minus 1. So my factorisation will be 6A minus 3 times 6A plus 2 all over 6 is equal to 0. Multiply both sides by 6. 6 times 0 is 6, so I've still got a 0 on the right-hand side. So that says 6A minus 3 is 0, or 6A plus 2 is 0. This says 6A is equal to 3, so A is equal to 3 on 6. This one says 6A is equal to minus 2, so that'll be minus a third sitting in there. And once again, I get 2 solutions. So, we're busy solving quadratic equations, and our method thus far is to try and factorise them. And we're doing a whole lot of examples of that. And I think I'm up to E. So let me have a go at E here. 5x squared is equal to x. And as always, try to get it in the form of quadratic trinomial equal to 0. And so here it's 5x squared minus x equal to 0. And in this case, I don't need to do my alpha plus beta trick at all, because I can see that this has a common factor of x. And so I can just take out my common factor of x, and I'll have 5x minus 1. There's my factorisation, so therefore either x is 0 or 5x minus 1 is 0. And so that says, whoops, if I get here, x is equal to 1/5 or x is equal to 0. So that one was a simple one in amongst the more difficult ones. So now I'm going to have a go at F here. So F says F 2n squared minus 20n equals to 20n plus 48. So we'll do our usual trick of putting everything onto the left-hand side. I have 2n squared minus 20n minus 48 is equal to 0. Now, I could factorise that, but my life is made a little bit simpler if I recognise the fact that 2 is common to all those terms. So in this case, I'm actually going to divide by 2 here. In fact, I'll do it this way. I'll write it. It's 2 lots of n squared minus 10n minus 24 is equal to 0. Now I can divide both sides by 2. So here I have n squared minus 10n minus 24 is 0. And I'm now down to a coefficient here of 1, which means that I can just say alpha plus beta's minus 10, alpha times beta is minus 24. And so I think my numbers are going to be in there, minus 12 and plus 2. Minus 12 times 2 gives me minus 24. Minus 12n plus 2n is minus 10n. So I'm assuming that you can get from that step to that step. That's your factorisation again. And having done that, that says n minus 12 is equal to 0 or n plus 2 is equal to 0. So n is either 12 or minus 2. And were we to be worried, we could go back and substitute into the original equation and check whether we got it right or not. I'm not going to. I think I got it right. Okay, so G looks awful, but the important thing is, as we look at that equation, there's certainly an x squared there, there's an x, a number, an x squared. So the largest power that occurs there is x squared, so that is still a quadratic equation. I'll be able to simplify this. So this is still quadratic. So we can use our methods that we've been doing so far. What I'm going to try and do is write it as quadratic trinomial equal to 0 and then try to factorise it. So what I want to do is put all the terms onto the left-hand side. So I'm going to have 3x squared plus 2x squared. That will give me 5x squareds. I've got plus x, and then when I bring the 12x over, I'm going to have plus 12x. So that's going to be plus 13x. And the only number I've got here is 6, so subtract that, and I'll have 5x squared plus 13x minus 6. And there it is now written as a quadratic trinomial equal to 0, and I should be able to, all being well, factorise that. So here we go. Alpha plus beta has to be 13, and alpha times beta has to be 5 times minus 6. So minus 30. So these are alpha and beta of opposite sign. The largest one's going to be positive, and I want factors of that, so I reckon 15 and minus 2 are going to work. So that says alpha equal to 15, beta is equal to minus 2. 15 times minus 2 is minus 30, 15 plus minus 2 is 13. So they're my numbers, and so this factorises as 5x plus 15 times 5x minus 2 all over 5 is equal to 0. As I say, the hardest part here is actually doing the guesswork on those, but you can be systematic. What are the factors of 30? 30 and 1. 15 and 2, 10 and 3, 6 and 5, I guess you've got as well. Okay? So just try them. Just go through and try them. Okay, here I'll multiply both sides by 5, and 0 times 5 is 0, so that just becomes that. And so I have, therefore, 5x plus 15 is 0, or 5x minus 2 is 0. So this gives me x is minus 3, this one gives me x is 2/5. And there are my solutions. Yeah?
Seeing as alpha can also be negative 15 and beta can be 2, wouldn't that change?
No, because they would add to minus 13. that guess will be unique. The reason I chose alpha is because that was positive. I knew the larger of the two numbers had to be positive. Yep. Okay, the last one says x plus 8 times x plus 2 is equal to 16. And this one's put in here to try to trick you, I guess, or to make you think. Now, interesting, you say, look, I've got two numbers that multiply to 16. So therefore, maybe I can guess what these numbers are. But the thing is, you can't, because I know, for example, that 16 is 16 times 1, or it's 8 times 2, or it's 4 times 4. I don't know which one of these should be the case sitting in here. So what I need to do is I need to make this right-hand side 0. Because I know if I multiply two numbers to give 0, one of them has to be 0. So in this case, to solve it, I actually have to expand out the brackets and then subtract the 16. So I will do that. Here, expanding out the brackets via my FOIL, I'll get x squared plus 2x plus 8x plus 16 is equal to, this one comes out to be easy. Now I subtract 16 from both sides, and I end up with x squared plus 10x is equal to 0. Now I can factorise. And this one has a rather simple factorisation because I can just take x out, and I have x plus 10. Now I have two numbers that multiply to give 0, therefore either x is 0 or x plus 10 is 0. So x is minus 10 is the other possibility there. Okay, this idea of two numbers multiplying together, one of them has to be 0, only works when the right-hand side is 0. Okay, that's our moral of this story. Right-hand side has to be 0 before factorising works. So even though this is factored up here, because the right-hand side isn't 0, didn't help us in there. And I think we've got through our big list. Have we finished our big list? Yes, we have. Okay. So therefore, we can solve lots and lots and lots of quadratic equations. We can't, however, solve them all yet. So let me sit that there. There are still some quadratic equations because we're not very good at factorising all of the quadratic equations. So